Good morning viewers. I am going to give a lecture on transducer. The front end of any instrumentation system is transducer. Now I am going to discuss three concepts under this topic. First one is what is transducer, how the transducer is classified, in what way the transducer are used for the measurement of an event, that is both electrical and non-electrical quantity. Before that, I am going to discuss the importance of measurement. What is measurement? Measurement is made by comparing the unknown quantity with predefined or predetermined standard values. I just explain with the help of two examples. The length of the wall is expressed as 3 meters after comparing it with pre-marked tape kept at standard environmental conditions. The weight of an object is said to be 2.4 kilogram after comparing it with standard weights. Measurement is nothing but quantifying an event or a thing. Next, I am going to discuss the functional block diagram of the measurement of a system is shown in figure 1. Actually, it consists of 3 different blocks. The first block, namely transducer. Second block, namely signal conditioner. Third block, namely data presenting device. Now I am going to explain all 3 different blocks very detailedly. The first block, namely transducer. Transducer that produces the output signal, which is a function of measured physical quantity. Input signal quantity for most instrumentation system is a non-electrical quantity. Input signal quantity may be displacement, velocity, acceleration, etc. The output signal quantity may be a current, voltage, or a frequency. For example, a flopper nozzle displacement is converted into air pressure, which is a transducer. The output of the transducer is given to second block, namely signal conditioners. The output of the transducer is not suitable for direct use, so that it modifies into convenient form for further processing. The processing signal may be amplification, attenuation, modulation, demodulation, etc. are to be performed. Signal conditioner performs one or more such functions. The output of the signal conditioner is given to third block, namely data presenting device. Data presenting device is used to present the measured physical quantity to the observer in the form of analog indication or digital indications, indicating instruments like CRT, ammeter, voltmeter, printer, etc. These are the devices are used to present the measured physical quantity to the observer in a suitable form. These are the 3 different blocks which is highly useful for the measurement system in instrumentations. Next, I am going to focus what is the definition of transducer. Transducer is a device which converts one form of energy into another form of energy. Or in other words, transducer is a device which converts non-electrical quantity into electrical quantity. The ISA, International Society Measurement and Control, USA, gives the broad definition of transducer as transducer is a device which converts a physical phenomenon into electrical, hydraulic, or pneumatic output signal. Most of the people in the instrumentation side that gives another definition for transducer is a sensing device which converts mechanical energy into an electrical energy. Many physical parameters like displacement, velocity, acceleration, light intensity, pH value, humidity, all are converted into electrical variations by using transducer. Transducer produce electrical output signal only simulated by mechanical or non-mechanical input. A photoconductor light intensity is converted into change of resistance. A piezoelectric crystal, an acceleration is converted into electrical potential. A strain gauge, a force is converted into change of resistance. But all these effects that produce electrical output, these electrical output can be determined only by means of standard methods. Another name for transducer is pick up. Next, my object is I am going to discuss the second concept, so called how the transducer is classified. Transducer is classified into 5 types, namely on the basis of principle of transduction form used. Second one is as primary and secondary transducer. Third one is as passive and active transducer. Fourth one is as analog and digital transducer. And finally, transducer and inverse transducer. Now I am going to explain all these classifications very detailedly. First classification as on the basis of principle of transduction form used. The transducer can be further classified into 3 types, namely resistive transducer, inductive transducer and capacitive transducer. But all these transducer, how the input quantity be converted into electrical output, that we will discuss with the help of some illustrations. First, we discuss resistive transducer by using some examples. For the discussion of resistive transducer, I am going to give 3 examples. First one is potentiometer device. The working principle is position of the slider is varied by applying external force, so that it gives a change in resistance in a potentiometer circuit or a bridge circuit. Potentiometer device is used to measure pressure and displacement. Another example for resistive transducer is resistance thermometer. The working principle is the resistance of the pure metal wire with a large positive temperature coefficient varies with the temperature. It is used to measure temperature, heat and radiant. And finally, thermistor. The working principle is resistance of certain metal oxides with a large negative temperature coefficients varies with the temperature, but it is used to measure temperature and flow. Another type, capacitive transducer, in which I am going to give 2 examples. Variable capacitance box. The distance between 2 parallel plates is varied by an applying external force, so that it gives change in capacitance. It is used to measure pressure and displacement. And another example is dielectric gauge. Working principle is by changing the dielectric or dielectric constant, it produces a change in capacitance. It is used to measure liquid level and thickness. And finally, inductive transducer, in which I am going to give one example, that is differential transformer. Working principle is output of the 2 secondary windings changing by positioning the magnetic core by applying external force. Inductive transformer is used to measure pressure, force and displacement. And the second classification is as primary and secondary transducer. What is primary transducer? What is secondary transducer? Primary transducer is a transducer which converts one physical quantity into another physical quantity. Secondary transducer is a transducer which converts one physical quantity into another electrical quantity. I explain this classification with the help of one illustrations, that is the measurement of pressure using Bourdon's tube and LVDT setup is as shown in figure 2. Actually, this setup consists of Bourdon's tube and LVDT. Bourdon tube is usually made up of elastic properties of metallic elements, is specially designed for construction of pressure and force transducer. LVDT consists of one primary coil and 2 secondary coils. There is one magnetic core is placed in between 2 coils. Output can be measured across the 2 secondary coils. Measured physical quantity, that is pressure, is applied at the fixed end of the Bourdon's tube. On account of very high pressure, the free end of Bourdon's tube is tilted and thereby it made a displacement. The displacement of the free end causes movement of magnetic core in between two coils. Due to the movement of magnetic core in between two coils, it produces some output potential across the two secondary windings. Output potential of the two secondary windings is directly proportional to movement of magnetic core. Movement of magnetic core is directly proportional to displacement of free end is directly proportional to applied pressure. In this way, the pressure is measured with the help of Bourdon's tube and LVDT setup. But in this setup, there are two stages of transductions are taking place. Namely, pressure is converted into displacement using Bourdon's tube, and hence it is called a primary transducer. Displacement is converted into electrical potential using LVDT, and hence it is called a secondary transducer. Primary transducer acts as a mechanical device, whereas LVDT acts as electrical device. Third classification as passive and active transducer. First we will discuss passive transducer. What is passive transducer? Passive transducers are those which require an auxiliary power source to produce their output. Hence it is called externally powered transducer. Examples for passive transducers are resistive transducer, inductive transducer, and capacitive transducers. I explain passive transducer with the help of one example, that is the measurement of linear displacement using potentiometer is as shown in figure 3. Actually, this circuit setup requires two components. One is potentiometer and another one is power supply. Connections are made as shown in figure. Output potential can be measured using the relation V0 equal to Xi by L into Vi, where V0 is output potential, Vi is input potential, Xi is linear displacement, L is total length of potentiometer device. From this relation, we can easily determine the linear displacement Xi. Xi equal to V0 by Vi into L. In the absence of external power supply, the transducer cannot work. That is why potentiometer is only under the category of passive transducer. As already mentioned, passive transducer is a transducer which require an auxiliary power source to produce output. Hence it is named as externally powered transducer. Without power supply, potentiometer cannot work. That is why potentiometer is under the category of passive transducer. Then we go for active transducer. Active transducers are those which do not require an auxiliary power source to produce their output. Hence it is called self-generating transducer. Active transducer are used to measure force, velocity, acceleration, light intensity, and displacement. I explain active transducer with the help of one example. The measurement of acceleration using piezoelectric crystal is as shown in figure 4. Piezoelectric crystal is sandwiched between two metallic electrodes. The entire sandwich is placed at the top of the base. Above the sandwich, a fixed mass is placed. Measured physical quantity and acceleration is applied to the bottom of the base. On account of acceleration, the mass exerts certain amount of force, and thereby it produces some output potential across the two metallic electrodes. The output potential is directly proportional to force, and force is directly proportional to applied acceleration. In this way, an acceleration can be measured with the help of piezoelectric crystal. But the definition of active transducer is a device which do not require any auxiliary power source to produce our output. But in this example, we never give any external power supply. From the measured physical quantity itself, it attains energy and thereby it produces output potential. That is why piezoelectric crystal is only under the category of active transducer. Fourth classification as analog and digital transducer. But this classification on the basis of output, which may be a continuous function of time or which may be a discrete steps. First we will discuss analog transducer. Analog transducer is a device which converts input quantity into analog output, which is a continuous function of time. Analog transducer examples are thermistor, LVDT, strain gauge, etc. Digital transducers or transducers is used to convert input quantity into electrical output only in the form of pulses. Examples are optical encoder. And finally, transducer and inverse transducer. Transducer means, so far we have learnt, transducer is a device which converts non-electrical quantity into an electrical quantity. But inverse transducer is a device which converts electrical quantity into a non-electrical quantity. Examples are piezoelectric crystal, ammeter and voltmeter. Piezoelectric crystal is an inverse transducer because on applying electrical potential across its surface so that it changes by dimension and causing mechanical displacement. An ammeter and voltmeter is also under the category of inverse transducer because current and volt can be converted into mechanical displacement, that is conversion of electrical phenomenon into non-electrical phenomenon. That is why piezoelectric crystal, ammeter and voltmeter all are under the category of inverse transducer. Inverse transducer is highly useful in feedback measuring systems. Transducers are mostly used in instrumentations for measurement and control and a systematic study of computing and networking. With that, I conclude my talk on transducer. Now I am going to give a brief summary on transducer. So far we have learnt three concepts, namely what is transducer, how transducers are classified, in what way the transducers are used for measurement of an event, that is both electrical and non-electrical quantity. The first concept we discussed, there are number of definitions for transducers, but all are giving same meaning. Transducer is a device which converts one form of energy into another form, or in other words, transducer is a device which converts non-electrical quantity into an electrical quantity, or in other words, transducer is a sensing device which converts mechanical energy into an electrical energy. But all the definition, it seems to be the conversion from one phase to another phase. But the second concept, the classification, we have discussed 5 classification on the basis of principle of transduction form used 1, second as primary and secondary transducer, third one is as passive and active transducer, fourth one is as analog and digital transducer, and finally transducer and inverse transducer. But all the classification we have studied with the help of some examples. Generally, the transducer is highly useful in instrumentation system for measurement of control and systematic study of computing and networking. So, with the help of little bit flavor on transducer, we discussed very detailedly in forthcoming classes. With that, I conclude my lecture. Thank you.